Welcome everyone. Welcome to Physics by Aaron. I'm very happy to welcome you all in this free foundation physics course. In this foundation physics course, I am covering all the basics that you need for your competitive physics exams. For example, CSIR NET, GATE, JEST, JAM, whatever exams you are preparing for, even TIFR and BARC, all the exams need some basics of physics and mathematics. In this series, I have already taken many lectures, graphical analysis, Taylor series, Dirac delta function, and so on. You can find all of those lectures, notes, quizzes on our website, Physics by Aaryan, or on our iOS app, Physics by Aaryan. You can join any course for free and you can see the foundation physics course available there. If you want to see a detailed video on this, you can go to our YouTube channel and see how you can access the foundation physics course. I have already uploaded a demo that how you can access the free lectures and all the content. Now, moving to next topic, today I want to cover the topic which is limits. Now, limits has been directly asked many times in many exams, especially IIT JAM, TIFR and JEST. Sometimes it has asked indirectly in CSIR NET, for example, in statistical mechanics and in many other subjects. So it is very important that we have a basics of limits, very nice, very good and nice. So limits, what is the meaning of limits itself? So many times it happens is that we cannot find the exact value. For example, let's say I have a function sine x by x, and I want you to give me the value at 0. What is the value of sine x by x at 0? So you will say, okay, let's put 0 in numerator and also in denominator. So you will get sine 0 by 0. Sine 0 is also 0 and divided by 0 is also 0. Now in mathematics, we do not know how to divide 0 by 0. So this is known as indeterminate form. Indeterminate means we cannot determine the value. So it is an indeterminate form. How do we deal with this? In order to deal with such problems, we have to use the limits. 0 by 0 is not only in one indeterminate form. In total, there are 7 indeterminate forms. For example, we don't know how to multiply 0 and infinity. We don't know what is 0 raised by 0. We do not know what is 1 raised by infinity. We do not know infinity minus infinity. We do not know infinity divided by infinity. 0 by 0, as I talk, we do not know. Also, we don't know infinity raised by 0. So in any problem, if any one of these things are coming up, it means it is an indeterminate form and we need to use limits. So what we do is this, that we find the value of fx very close to a. So let's say fx was indeterminate. So fx was indeterminate at x equals to a. So we cannot find the value of x at x equals to a. So what we do is we find the value of fx very close to a. So we won't find the value at x exactly at a, but we will find its value very close to a, very, very, very infinitesimally close to a. It means we find the value when x tends to a. This symbol means tends. So we are finding the value of f of x when x is tending to a. It is not a, but it is tending to a. So x is not a, but it is x is tending to a. So we find the value very close to a, and that we assume is our actual value. However, we cannot find actual value, but we can find the value very, very close to a. That is what we do. Now, in order to tend towards a, so let's say you want to come towards a, there are two ways. Either you can come from right side or you can come from left side. For example, if you have x equals to 0, so you can either come from negative side or you can either come from positive side. So if you come from right side, you say it is right hand limit. And if you come from left hand, we say it is left hand limit. So on the left side, x is slightly less than a, which means x is a minus h, and h is almost 0. And h is almost 0, very close to 0. So on the left side, the value of x is a minus h, means very, very less than a. And on the right side, the value is very, very little more than a. So it means your x is a plus h. Okay, so there are two ways to approach your point. Either you can approach from left side or you can approach from right side. Now, let me give you an idea. if you want to find a limit at x equals to a, if you want to know the limits of a function at x equals to a, the rule is right hand limit and left hand limit should be equal. So either you come from left side or you come from right side, your answer should be same. If this is happening, it means your limit exists at x equals to a. So how we can write that? So limit, left hand limit means our x is coming to a from negative side. So you can say a minus. It means x is coming towards a from the left side. And this means that your limit x approaches to a positive means your x is coming to a from right side. So once you solve both of these, your answer should be same. Okay, so you have to find the value of fx when your x is coming to a from left side, and you have to tell me the value of fx when your x is coming to a from the right side. And in both these cases, if your answers is same, it means your limit exists at x equals to a. Now let me give you an example so that you can actually feel this phenomena happening in front of you. Okay, so let's see. So your example is your fx is given as x square plus 2 when x is greater than or equals to 1. So this is your x equals to 1. If you are greater than or equals to 1, then your value of function is x square plus 2. But if you are less than 1, then your value of function is 2x plus 1. So let's find left hand limit. Left hand limit means we are approaching x from left side. So we are approaching x is approaching 1 from negative side. It means x is approaching 1 negative fx. So what is the value of fx when we are less than 1? The value is 2x plus 1. So I put a value of fx as 2x plus 1. Now what I will do is I will put my x as 1 minus h. Why 1 minus h? Because we are very slightly less than 1. We are very slightly less than 1. So I will put x as 1 minus h, and my h is approaching to 0. Because h is very small. It means we are very slightly less than 1. Okay, so let's just put it. So instead of x, I will put 1 minus h, and everything else remains same, and your h is now going to 0. Now just put h as 0 in this situation. What you will get is 2, 1 minus 0 plus 1, which is 3. So your left hand limit has a value 3. Now let's come to right hand limit. Now your x is approaching 1 plus, means you are approaching 1 from right side. What is the value for 1 greater than x greater than 1? So value for x greater than 1 is x square plus 2. So let's put the value of fx. So we put the value of fx as, sorry, here I should write x square plus 2. Okay, so if I put x as 1 plus h, so what will I get? I will get 1 plus h square plus 2. Very nice. Now I will just put h as equals to 0. So I will get 1 square plus 2, which is also 3. So either you come from right side or you come from left side. In both the cases, you are getting your answer as 3. It means your limit exists at x equals to 1. Okay, so that is an example which you can clearly see. Okay. Now let's move on to more examples. Now one of the example is limit x approaches to 3, and your function is x minus 3 by mod of x minus 3. So this is your function, and we are approaching 3. Now there are two ways. One we will approach from left side, and another we will approach from right side. But before doing that, let's see what is x and mod of x minus 3. I have already discussed this in my graphical analysis lecture, that mod of x minus 3 will be minus of x minus 3 if x is less than 3, and it will be simply x minus 3 if x is greater than 3. So just put the values of this here. So you can see x minus 3 by minus x minus 3 will give you minus 1, and x minus 3 by plus x minus 3 will give you 1. So your function has a value minus 1 if x is less than 3, and your function has a value 1 if your x is greater than 3. So you can clearly see, if this is 3, the value of function on left side is minus 1 and on right side is 1. So if you approach from left side, your value is minus 1. But if you approach from right side, your value is 1. So these both values are not equal. It means your limit does not exist. Because when we are coming from left side, your value is -1. And when we are coming from right side, our value is 1. So it means our limit does not exist because the values coming from left side and right side are not equal. One more example which I want to give you is greatest integer function. Now, what is greatest integer function? The symbol is square bracket x. So square bracket x is equals to 0 if you are between 0 and 1. So if you are between 0 and 1, your value will be 0. If you are between 1 and 2, your value will be 1. So on. If you are between 2 and 3, your value will be 2, and so on. So you want to approach 1. So your x is approaching 1. Now very carefully see. So this is your 1, and this is your 0, and this is your 2. So very carefully see, when I am very less than 1, it means I am between 0 and 1. So my value will be 0, because greatest integer function gives you 0 if you are between 0 and 1. Now, if I'm very slightly more than 1, then it means I'm between 1 and 2. It means my value is 1. So you can clearly see, if I approach from left side, my answer is 0. But if I approach from right side, my answer is 1. Both of these are not equal. It means limit does not exist. So I hope with these three examples, you understood that when limit exists and when limit does not exist. Okay. Now I want to present you the 4 cases which you can find in limits. Any limits question, you see four things happening. Number one thing is the limit exists but value does not exist. What do I mean by this? Limit exists but value does not exist means, let's say you have a function. The function is x square minus 3 by x minus 3. And I ask you that find the limit and the value at x equals to 3. So do me a favor and tell me what is the value at x equals to 3, and also tell me what is the limit at x equals to 3. If you find the value at x equals to 3, you can clearly see that you will get 0 by 0. On the numerator also you will get 0, and in denominator also you will get 0. And 0 by 0 you cannot find. It means your value does not exist. Now, but can we find limit? Can we find? Let's try. So what we do actually here is, we find limit when x approaches 3 and our function is x square minus 3 by x plus 3. What I can do is, very smartly, instead of doing a long process coming from left side, coming from right side, I can do one smart thing here. What I can do is, I will write x square minus 3 as x minus 3 into x plus 3. So you must have heard the identity that a square minus b square is, sorry, here the function is 9. Very sorry here. So here, if you see, it is 9. Okay. So function should be 9, because if you put 3 here, then only your limits will be 0 by 0. Okay. So your function is 9. Now you can actually check, if I put 3 here, 9 minus 9, 3 minus 3, it is 0 by 0. So x square minus 9, I can write as x minus 3 into x plus 3. Okay, fine. This is fine. A square minus b square equals to a minus b into a plus b. Now you can clearly see there is x minus 3 in the numerator and x minus 3 in the denominator. Can I cancel this? So the basic question is, can I cancel this? So the answer is no, if x is 3. If x is exactly 3, you cannot cancel this, because otherwise you are cancelling 0 and 0. Because if x is exactly 3, x minus 3 is 0, and in denominator also x minus 3 is 0, so you are cancelling 0 by 0. You cannot cancel 0 by 0. But if x is not exactly 3, but very close to 3, then you can cancel. If, I will repeat this, if x is 3, you cannot cancel them, because then you are cancelling 0 by 0. But if x is not exactly 3, but very close to 3, then you can cancel them, because then values will be very small, like 0.001, 0.001, and you can cancel these out. And what you are left with is x plus 3. And now simply put value of 3 here and you will get 6. So your limit exists, but value does not exist. That was the reason I didn't cancel it when I was finding the value. When I am exactly at x equals to 3, I cannot cancel them. But when I am very close to x minus 3, I can cancel. So that is why your limit exists, but your value does not exist. Okay, so this was a case number 1. Case number 2 is your value exists, but limit don't exist. When that can happen? So in the previous question, before this question, we did greatest integer function. So greatest integer function question was ki limit x approaches to 1 and greatest integer. So if you just put value 1 here, so just put the value 1 here. So what will be the value of greatest integer function? It will be 1. But if you try to find its limit, then we just solved above that limit does not exist. We saw the reason that why limit does not exist for greatest integer function. So limit does not exist, but value exists. So if you just simply put 1 in greatest integer function, you will get 1. So value is defined, but limit is not defined. This is the case number 2. Now case number 3, I am leaving up to you. The example you can clearly see here. But the case number 3, what does it tell is limit exists, value also exists, but they are not equal. They are not equal. So you can actually see this example in the notes that, or I can also explain you, there is not an issue. So limit and value both exists. So let's try to see the value. So let's see at x equals to 2, what is a value? At x equals to 2, your function value of a function is 3. So you can clearly see this function. This function says, when you are at x equals to 2, your value is 3. But when you are not at x equals to 2, your value is x square minus 4 by x minus 2. So when you are at x, exactly at 2, your value of function is 3. So your value of this function is 3. But what about limit? If we talk about limit, we simply put the function, which function? Now we are not at exactly 2. We are close to 2. So what function we will put? We will put x square minus 4 by x minus 2. And this gives you an answer 4. How? I will explain you in the later steps. When I will telling you that how to find limits, there I will explain you how you can find this limit. You can find this limit very easily. But for now, you have to trust me that value of this limit will be 4. So the value of this limit is 4 and the value of function is 3 and both of them are not equal. Okay. So this is your case number 3. The case number 4 is very interesting. That value also exists, limit also exists, and both of them are equal. If this is the case, this means your function is continuous. Your function is continuous at x equals to a. So if at x equals to a, limit exists, also value exists, and both of them are equal, then what we can say is your function is continuous at x equals to a. This is a very important rule. I hope that you all understood till here. If you have any doubts in the lecture or anywhere, if you feel that, okay, I have done some steps wrong, or there is some calculation mistakes in the in my slides or whatever in the notes or something, you can please message me on Telegram, or you can message, or you can start a new discussion below this video also. I am very actively replying to all the doubts which are coming to my way. Okay, I will be happy to give you all the answers. Now, I will really suggest you to read the notes as well. I have provided the digital notes of this topic. Those notes have so many solved examples. So you will actually get a feeling that how to do more and more problems, and that will make your concepts much clearer. So please read those notes. You can find those notes on our website and an app. Okay. And after this topic, you will also find a quiz. So also attend that quiz, so you can also challenge yourself that how much you have understood the concept. You can find the quiz on our app or on website. So now let's move on to next part. Methods to find limits. There are multiple methods to find limits. Number one method is substitution. So the easiest method is, before you start doing so many complex things, the basic thing is just put the value and see if you're getting an answer or not. So question in front of me is limit x approaches to 0, and this is my function. Before I start doing something crazy, the first thing that I should do is just put the value. So put the value of x0. So I will get under root 1 plus under root 1 divided by 1. Under root 1 is 1. So 1 plus 1 will be 2, divided by 1 will be 2. So you are getting an answer 2. So if you are getting a value, that's it. You don't have to do anything crazy. You have got your answer. Move to the next question. Okay. So before starting something crazy, just check that if you are getting your answer or you are getting some indeterminate form. If you're just getting an answer, that is your answer. Okay. If you need some sort of, you are getting indeterminate form, only then you need some sort of other methods to solve the problem. Okay. Now let's move on to next part. So next is factorization method. So your question is limit x approaches to 1, x square minus 1 by x minus 1. So what is our rule? First check that are we getting our answer or we are getting something crazy. So just put the value of 1 here. 1 minus 1 0 and 1 minus 1 0. So we are getting 0 by 0. It means we have to do something else. So one way to do is we can actually factorize. So how we can factorize? We can write x square minus 1 as x minus 1 and x plus 1. And there is x minus 1 in the bottom as well. And we can cancel x minus 1 and x minus 1. Why we can cancel? Because we are not exactly at x equals to 1. If we are exactly at x equals to 1, then we have 0 by 0 and we cannot cancel them. But if we are very close to x1, it means we have a very small numbers and we can cancel very small numbers. So we can cancel x minus 1 and x minus 1. And we simply put the value of 1 in this and we get an answer of 2. So our answer is 2. Similarly, you can do this question. X square minus 1 by x square plus 3x plus 2. You can factorize numerator as well as denominator. We all know how to factorize. We can factorize quadratic equation, cubic equations. I hope you all know these things. Any BSc, MSc student must know that how to factorize. Okay. So once you factorize and you cancel the terms and put the value, you will get an answer of minus 2. Okay. It's a very basic and simple mathematics. Okay. Now there is one important formula. So other ways to find. So one method we learned is just substitute. Second method we find is factorize. The third way we are going to find is important formulae. There are some other important ways which are very helpful in finding the limits. One of them is if limit is x approaches to a, limit is approaching a, and you have xn minus an, xn minus a raised to power n divided by x minus a, the answer to this is n a raised to power n minus 1. Okay, so this is an important rule. Now let's use this in one example. So the question in front of you is ki limit x approaches to a, x raised to power m minus a raised to power m, and x raised to power n minus a raised to power n. So I can convert this into this form. How? So what I will do is in numerator, I will divide by x minus a and multiply by x minus a. Now I have this form. What I need. Also in denominator, I will multiply by x minus a and divide by x minus a. Here also I have the same form. And I can cancel this x minus a and x minus a. So if I cancel this, what will be this equals to? This will be equals to m a m minus 1 and this will be equals to n a n minus 1. So if I put these values, I will get an answer of m by n, a raised to power m minus a raised to power n. So you should remember this formula. It is used many times in many questions. Okay. Now, this was the first important formula, which will help you to find the limits. Now, let's move to the next part. What if we have infinite limit? So your x is approaching infinity. So always remember one rule, 1 by infinity is 0. So if denominator is infinity, your answer is 0. Okay. Now, what we can do is in these kind of questions, whenever limit is infinity, we should try to bring x in the denominator. Always try to bring x in the denominator whenever you have a limit question. How can I bring x in the denominator? So what I can do is divide numerator and denominator by x square. So whatever is a maximum power, let's say your maximum power here is x square. So divide it in numerator as well as in denominator. This is always a rule. So divide, I will say divide maximum power, in this case x square, in both numerator and denominator. Always follow this rule whenever your limit is infinity. So if I do this, if I divide 2x square by x square, you will get 2. And 3x by x square, you will get 3 by x. Similarly, in the bottom, if you divide 3x square by x square, you will get 3. And if you divide 4 by x square, you will get 4 by x square. Now just put the value infinity. So you will get 2 plus 3 by infinity divided by 3 plus 4 by infinity. So whenever infinity is in denominator, answer is 0. This is also 0. So you will get 2 plus 0 divided by 3 plus 0, that is 2 plus 3. So your answer is 2 plus 3. So I hope that you understand how to solve the problem when the limit is infinity. Please follow the notes. There are many solved examples there. So you will get a very good practice of all these rules which I am teaching you. I am giving you a brief idea and 1 or 2 examples so that you actually understood that how to approach the problems. But now it is your responsibility or your duty to actually go to the notes and solve all the examples which are written there. Okay, I have compiled all the examples which you might need. The third rule, which I will say is the most important rule or the most important part of the lecture, which I will say is L-hospital rule. So L-hospital rule tells you that, let's say, I will explain this rule using an example. So you have a question. So you have a question that limit x approaches to 0, a raised to power x minus b raised to power x divided by x. What is our first rule? Our first rule is put the value and see if we are getting something crazy or not. So if I put x equals to 0, I get a raised to power 0, b raised to power 0 divided by 0. A raised to power 0 is 1, b raised to power 0 is 1, 1 minus 1 is 0, 0 by 0. So we are getting 0 by 0. Whenever we are getting 0 by 0, we can use L-hospital rule. What does L-hospital rule says? L-hospital rule says differentiate numerator and also differentiate denominator. So if we differentiate numerator, one differentiation rule that you might know is if we differentiate a raised to power x, the answer is log a raised to power multiplied by a raised to power x. If you don't know this, please see my basic mathematics notes. So differentiation of a raised to power x is a raised to power x will remain as such multiplied by log a. So if I differentiate my numerator, what I will get? Log a into a raised to power x plus log b into b raised to power x. And in denominator, if I differentiate x, I will get 1. Now you can easily put the value of 0. So if you put the value of 0, a raised to power x will become 1. And b raised to power x will also become 1. So you will be left with log a plus log b. And log a plus log b is nothing but log ab. Okay, so you can, using L-hospital rule, you can find these kind of questions. L-hospital rule is always very important. So whenever you have 0 by 0 form, differentiate numerator, differentiate denominator, and then just put the value. That's it. If still you get 0 by 0, again repeat the process. Again differentiate numerator, again differentiate denominator, then put the value 0 or whatever is the value of limit. Again, if you get 0 by 0, keep on repeating this. Differentiate numerator, differentiate denominator, and just put the value. Okay. In most of the cases, your limits will be solved using L-hospital rule. Sometimes you need factorization or other methods also to do this. Okay. Okay. Now let's move to next part. What if you have log or exponential? I have given 3 formulas here. You don't need to remember these formulas. So whenever a raised to power x minus 1 by x and x approaches to 0, you get ln a. All these 3 rules you can prove using L-hospital rule. So I will really recommend you to read these 3 rules in the notes and then just try to prove this using L-hospital. That will be your exercise. I can give one of them to you so that you can actually see how you can solve it. So in first problem, let's first of all check that are we getting something crazy. So just put 0. So a raised to power 0 minus 1 by 0. A raised to power 0 is 1 minus 1 by 0, which is 0 by 0. So definitely we are getting 0 by 0, which is something crazy. So once we get 0 by 0, we can use L-hospital rule. So now let's use L-hospital. So we will differentiate numerator. A raised to power x. What is the differentiation of a raised to power x? A raised to power x into log a. What is the differentiation of minus 1? 0. And what is the differentiation of x? 1. Now we can simply put x equals to 0. So if we put x raised to power 0, it will be a raised to power 0 into log a. And a raised to power 0 is 1. It means your answer is log. And this is what I have written here. So you can verify all these 3 formulas using your L-hospital rule. Okay. Now, the next part is very important, and in these questions I have actually seen coming in IIT JAM, JEST and TIFR. 1 raised to power infinity is another indeterminate form. Many people know how to solve 0 by 0. L hospital rule, most of the BSc MSc students know. But this rule, most of the students do not know. And questions have came directly from this rule. And no coaching institute or no book has very nicely covered this topic. So I have actually seen and given you one formula which will help you in solving this problem very easily. So let's see that formula. Let's see how you can do it. So whenever you have one raised to power infinity form, so let's check. In first case, what rule I'm giving you is 1 plus x raised to power 1 by x. So let's just put the value 0. So what you get is 1 plus 0, which is 1, and 1 by 0 is infinity. So you are getting 1 raised to power infinity form. How do you solve problems in this situation? So what you do is you say e raised to power limit x approaches to 0. Whatever is your limit, you say limit x approaches to 0. Then whatever is inside, just write this as such and subtract 1. And whatever is in the power, just multiply that. Okay, I will repeat again. Whenever you have 1 raised to power infinity form, how do you solve those problems? E exponential raised to power your limit. So I wrote x raised to power limit x approaches to 0. Now, whatever is inside your bracket, write that as such and subtract 1. So subtract 1, and whatever is in your power, multiply with that. So we multiplied with 1 by x. So 1 and 1 will cancel out. So you will be left with x multiplied by 1 by x. That will be 1. So this will give you e raised to power 1. So you can simply see you get an answer of e raised to power 1. Similarly, we can verify this in third as well. You can verify yourself in D and D. I will verify this in third for you. So how we can do is, again, the same process. It is giving you 1 raised to power infinity form. So how I can do is e raised to power limit. Whatever is inside bracket, I will write as such and I will subtract minus. And whatever is in the power, I will write here. So you can actually check 1 and 1 will cancel. Lambda x by 1 by x will be e raised to power lambda. So your answer will be e raised to power lambda. Okay. Now let's practice some difficult question related to this rule. So now I am asking you to find this limit. First of all, let's check, are we getting 1 by raised to power infinity form or not? So let's put n as infinity. Here n is given instead of x. So let's put n infinity. So you will see 1 plus 1 by infinity is 0 and infinity. So definitely you are getting 1 by infinity, 1 raised to power infinity. What is the rule I mentioned? E raised to power limit. Whatever is in the bracket, write that minus 1. And whatever is a power, multiply with that. So what you will get, 1 and 1 will cancel out. You will get c plus dn, which is here, and divided by a plus bn. Now what you can do is just take, as I mentioned, whenever the power is infinity, whenever the limit is infinity, what do you do? What is the rule that you have to follow? So what you have to follow is divide with the maximum power. So maximum power of n is 1. So I will divide entire with n. So if you divide c by n, you will get c by n. If you divide dn by n, you will get d, and similarly in the denominator. Now, if you put n as infinity, c by infinity 0, a by infinity 0, so you will be left with e raised to power d by b. So this is a rule to find 1 raised to power infinity kind of problems. Always remember this. This is a very important, and questions have directly came in the exams from this rule. Okay. Yeah, very nice. Okay. Next thing, trigonometry rules. Many times in limits, we are given trigonometric functions, and how to find limits in that case. You can find the limits simply by using L'Hospital rule. So for example, limit x approaches to 0, sine x by x. So now if you put 0 and 0, you are getting 0 by 0 rule, because sine 0 is 0, divided by x is also 0. But how you can solve this? So just differentiate top and bottom. So if you differentiate top, you will get cos x. If you differentiate bottom, you get 1. And now if you put 0, cos 0 is 1. Similar thing you can do for tan x. Similar thing you can do for sine inverse x. Just differentiate on numerator and denominator and put the value, you will get an answer. So it's not a big deal. Let's do an example to understand this. So question is given to you as sine square 2x by x square. So are we getting 0 by 0? Yes, sine 0 is 0. X square means 0 raised by square is 0. So we are getting 0 by 0. So we have to come to the L'Hospital rule. So let's differentiate. Sine square x means 2 power will come in forward. Sine 2x, cos 2x. And if we differentiate that using chain rule, 2x differentiation will be 2. And in the denominator, x square differentiation will be 2x. So we can cancel this 2 and this 2. And we can write 2 sine 2x cos 2x as sine 4x. And in the denominator, we get x. Now you clearly see, carefully see that again we are getting 0 by 0. So what we do, we repeat the rule. So again differentiate sine 4x. So you get 4 times cos 4x. And if you differentiate x also, you get 1. Now put the value 0, then you will get answer as 4. So this is your final answer. 4 is your final answer. So I just used L'Hospital rule 2 times. Okay, you can use solve many of the examples in the notes given. Last topic which I want to cover is continuity. I have already given you a hint for this. I just want to explain or just formally give you this. For any function to be continuous, for your context, the information that you might need is this much information is enough regarding continuity. Okay, you don't have to go in very much depth that what is continuity in detail, but the information which I'm going to give you will be enough for your competitive exams, at least at BSc and MSc level. So for any function to be continuous at x equals to 0, so what I said is your left limit and right limit should exist, and it should be equals to the actual value. So your value should also exist. So limit and value both should exist and they must be equal. So this was our case number 4. You remember I discussed 4 cases. Out of those 4 cases, this was our case number 4. Okay. So let's see. Let's check the continuity for one function. So one function is given to you, which is e raised to minus x minus 1 mod. So is this function continuous or discontinuous? So let's check. Is this function continuous or discontinuous? Mod x. So mod x minus 1 will be equals to minus of x minus 1 if x is less than 1. And it will be simply x minus 1 if x is greater than 1. So I can put these values here and I will say my answer is e raised to x minus 1 if x is less than 0, and it is e raised to minus x minus 1. Sorry, here 1 and 1 will come. And it will be greater than 1 if, sorry, again, I will put this here. So what will happen is my value is e raised to power. So my negative and negative will cancel out. So my value is e raised to x minus 1 if x is less than 1. And my value is e raised to minus of x minus 1 if my value is x greater than 1. I hope that you understood this. Okay. If you got this idea, then simply first thing I will find is value. What is a value here? So to find the value, just simply put 1 here. So if you put 1 here, you will get 1 minus 1 and you will get e raised to 0, which is 1. Now you can do is you can find left hand limit and you can find right hand limit. I have already explained you how to find left hand and right hand limit. If you do so, you will also get answer 1. It means your limit is exist and the value of limit is 1. Also your value exists and the its value is also 1. It means your function is continuous. This is the basic fundamental rule. Okay, so please solve examples given to you in the notes. Very important. Once you solve those examples, then you never have to worry again about continuity in any of the questions in any of the BSc or MSc exam. So that's it about the today's lecture. And with this, I have covered basic mathematics topics. From the next class, I will be covering basic mechanics. So stay tuned. I will be uploading the next class tomorrow. See you all. See you in the next class. Bye-bye.